Okay, we shall start the class. Yeah, students, listen to the concept. Here, we have done the problems regarding the rigorous method of solutions and long transmission line, right? In that, we have equations Vs is equals to Vr into cos root yz plus Ir into root y by z into sin h root yz. We have got these two equations for the sending end voltage and sending end current. We have got these equations we have derived in the last class. What I'm going to tell you is this part, which is nothing but cos h root yz, is equal to cos h gamma L. It is equal to the cos h gamma L. This equation can be represented like this. This equation can be represented like this. Vs is equals to Vr cos h root gamma L. Why is it so? I'll be going to explain you now. See, in some of the textbooks, they will be going to give you the values for Vs is equals to Vr cos hyperbolic gamma L. This gamma L is called as the propagation constant. What is this called? Propagation constant. This gamma is called as propagation constant, we can say. And it is this gamma is again further simplified, which is nothing but the attenuation constant and phase constant. This gamma, what is this gamma called? Gamma is called as the propagation constant, we can say. Gamma is equals to propagation constant, that is equals to root over small y into small z. See why I am telling here. See, this is called as, this is multiplied if suppose this gamma, this propagation constant is multiplied with L. What it happens? This is equal to root over this L. If I take it to the inside that of the root, I will be having root y into L into z into L. Z into L. Okay. This is nothing but root over. See, the small y into L is nothing but the capital Y, which is nothing but the total admittance in the particular line. Total admittance in the particular line. What is the small z into L? Which is nothing but the total impedance in that particular line. The total impedance in that particular line is nothing but this Z, capital Z. And capital Y is nothing but the small y into length of the line. That is why we have multiplied in every of the problems, we have multiplied with the total length of the line, we are going to multiply. Here, we'll do the problem in terms of propagation constant. This formula we have been used, cos h gamma L plus ZC into IR sin h gamma L. This is changed to this form. We'll be going to continue the problem. We know these two formulas. In the earlier classes, we have discussed these two formulas. In CL Vadva, they'll be giving you as Vs is equals to Vr cos h gamma L. This means this value is equal to the same of this value. Why? Because gamma is nothing but root over small y into z. Gamma L is nothing but root over y into L into z into L, which is nothing but capital Y into z. That's what we have written over here. Cos hyperbolic gamma L is equals to cos of root y into z. Cos hyperbolic root y into z. Cos hyperbolic gamma into L is nothing but cos hyperbolic root y into z. See, and I can also write this ZC, which is nothing but the characteristic impedance. ZC is nothing but the characteristic impedance as, see here, which is nothing but root over Z by Y. What is this Z by Y? This Z is called as the impedance of the particular small length of the elementary length of the line. This Y is nothing but the admittance of that. If it is multiplied with the total length of the line, then we'll be getting the total impedance as Y. Total impedance as Z and the total admittance as Y. So I'll be having the equations now, ZC and gamma equations. I know what is gamma called. Gamma is called as the propagation constant, and ZC is nothing but the characteristic impedance, that is nothing but root over Z by Y. This is further simplified. This Z can be written as R plus J omega L. This Y can be written as G plus J omega C. In case of loss-free conditions, that is whenever we are using any good conductor insulating material, a good conductor as insulating material, then in that condition, R is equals to 0 and G becomes 0. G becomes 0. That is the conductance becomes 0 and resistance becomes 0. And the resistance becomes 0. In that conditions, resistance becomes 0 and conductance would be 0. So I place it 0, 0 over here. I will be remaining with J into omega L by J into omega C. That omega gets cancelled. I will be remaining with L by C. I can also define as at no load conditions. Here we Z0 is equals to root over L by C. Z0 is equals to root over L by C, which is called as the characteristic impedance at no load. We can say this is the Z0 is equals to root over L by C. This is one formula we are having in our hands, and ZC is equals to root over Z by Y. If at all, this formula is essential here in calculation. This formula is essential in this calculations. Vs is equals to Vr cos hyperbolic root Yz plus Ir into root Z by Y sin H Yz. Is is equals to Vr root Yz by sin H root Yz plus Ir cos this one. This can be written as this. How can I write this one? See here, gamma is equals to root Yz. Gamma L is equals to root Yz. I have placed Yz as gamma L. So here also, here Zc is equals to how much? Root over Z by Y. But 1 by Zc is nothing but, can you tell what is 1 by Zc? Root over Y by Z. Y by Z we can say. Y by Z. Root over Y by Z. 1 by Zc is equals to root over Y by Z. Zc is equals to, what is the value I am having? Zc is equals to root Z by Y. Root Z by Y I am having as Zc. So I will be placing in this space, I am placing Zc. So that I have got this value Zc. And IR is here. IR I am having. This is capital R we can say. IR I am having. Sin H root Yz. Sin H gamma L, in place of gamma L, I can place root Yz. So that I have replaced this equation with this. These both are same. Similarly, the Is is equals to Vr by Z. Why? Because 1 by Z is equals to root Y by Z. 1 by Z is equals to root Y by Z. So that Vr by Zc into sin H root over Yz. In place of root over Yz, can I place this one? Gamma L. This is the gamma L plus IR cos hyperbolic gamma L. This is the two equations what I am having. This equation is similar to this one, and this equation is similar to this Is equation. That means these two are similar equations. These two are similar and these two are similar. In some of the textbooks it may be represented like this. In some of the textbooks it may be represented like this. That is nothing but. See, from this equation, how can I get the ABCD parameters? What is A? A is equals to D is equals to cos H gamma L, and B is equals to how much? What I will be getting? Zc into sin hyperbolic gamma L, and C is equals to 1 by Zc into sin hyperbolic gamma L. We can write. We can write these three equations like this. We can write this. A is equals to D. ABCD parameters we can write from the equations like this. We can write the equations from the ABCD parameters like this. Okay. I hope you all understood why I am telling this means. First, in order to do this problem, what we are going to do just now, you need to know the difference between, see here, this formula is similar to this. If suppose in any of the textbooks you are given like this means, you need not worry about this. You need not worry about this. You can straight away change that one to the, your known formula is what? Your known formula is, these two formulas we are known. These two formulas, Vs and Is, we are known. So if at all they had been given this way, then you can change it into this form. Why? Because gamma L is equals to root over YL into ZL. That is nothing but capital Y into capital Z, which is nothing but this one. Cos H is common. Gamma L can be represented as root YZ. This is the known formulas, no? These two formulas are known formulas. These two formulas are known formulas for us. Change the content with the into the known formulas and find the equation so that it will be easy for you to understand. So that it will be easy for you to understand, and you can do the problem well. You can do the problem easily. Okay. Now let us see what is the how can you find these values? Let us see now. How can you find these values? Let us see now so that you have a clear idea. Okay. This is what about the what I mean to say is here Vs, you can write Vs in this way or you can write Vs in this way. These two are same. These two are same. And this Is equations also same. This Is equations also same. Let us see how to do this problem. Let us see how to do this problem right now. See, we are having a determine the sending end voltage, current, power and power factor. Determine the sending end voltage. That means the sending end voltage he had asked you to find, and sending end current he asked you to find, and sending end power he asked you to find, and sending end power factor he asked you to find. What else he asked you to find? These all. And after finding that, he is asking you to find the evaluate the ABCD parameters also. They asked you to say. So you have to find the ABCD parameters also with this. But the power delivered he had given you, it is a 160 kilometer length of the line. It is 160 kilometer length of the line. The power delivered is 50 MVA and 132 kV is nothing but the voltage. This is the power factor at the receiving end side power factor. See, the resistance had been given as this much and the reactance has been given. See, the resistance has been given this much. You have to find the reactance value and capacitive reactance and inductive reactance. Inductive reactance and capacitive reactance you have to find. Here he didn't give you the capacitive reactance and inductive reactance. He didn't give you the capacitive reactance and inductive reactance. He had given you only the resistance only. He had given you the resistance only. That is the given data. See, the spacing between the conductors are given in different ways. The spacing is different. That is 3.7 meters is one side. One side it is of 6.475 is on another side. It is on another side is 7.4 meters is on another side. So spacing between the conductors is also different here given. So for that, how to find it is a three phase transmission line. So for this condition, how to find the problem we'll see now. In the given data, he had given you only the resistance only. Resistance that you for the small length of the line he had given, you have to multiply it with total length of the line so that you will be getting the what? Total resistance what you are having, that you will be getting the total resistance. 0.1557 into 160. How much it is? It is of 24.9. Is of 24.9 ohms. Now let us see that GMD. Can we calculate the GMD over here? GMD is equals to what we have to calculate. This is the three phase, right? 3 into the different distances have been given. That is nothing but 3.7 into 6.475 into 7.4. 7.4 they had been given. It is of 5.6 meters you will be getting. It is of 5.6 meters you will be getting. 5.6 meters you will be getting. That is equal to 560 centimeters. That is equal to 560 centimeters we are having. That is equal to 560 centimeters we are having. Now let us see that Z is equals to what is the value I had given you? Z is equals to actual value is 0.1. Before going to the Z, we need to find the inductance. Inductance you need to find. Inductance formula is what? 2 into 10 to the power of minus 7 ln of GMD by R. GMD by GMR we can say into 160 total length of the line. Total length of the line is 160. In terms of kilometers are there, so I need to change into the Henry. So that is of value 2 into 10 to the power of minus 7 ln of GMD is what? GMD is 560 and GMR is nothing but, see what is the radius he had given you, the diameter he had given you as this much. Diameter by 2. Diameter by 2 gives you the radius, which is nothing but 1.956 centimeters by 2, which is equal to 0.978, which is equal to 0.978. 0.978 we are getting. Okay, that is multiplied with 160 into 1000 into 1000. Now which is equal to how much is this value? 0.2032 Henries. It is in Henries. So we want to find the omega L reactance. So what is this omega? Omega is 2 pi f, that is 314. 2 pi f is 314 into 0.2032. 0.2032 you will be getting, that is equal to 63.8. 63.8 you will be getting. Okay. Now let us calculate the C value. C is equals to 2 pi epsilon naught by ln GMR by GMD, GMD by GMR, GMD by GMR, you can say, into 160 into 160 into 1000, I can say. We can say it is of 1000. So these are simplification. I will be getting the equation as 2 into pi into 8.854. 8.854 into 10 to the power of minus 12. 10 to the power of minus 12 by ln of 560 by 0.978. 0.978. These are the calculations. I will be getting the value as 1.33 I will be getting the value as 1399 into 10 to the power of minus 9, I can say. This is 10 to the power of minus 9 farads. In terms of farads, I have got. Now, I am having resistance, inductance, capacitance in my hands. Now, let me do how to calculate what is ZC. What is ZC? I have to find. What is J omega C I'll be having? See, ZC is nothing but just now I have shown you root over Z by Y. Small z by small y. Small z by small y. Which is equal to, what is this y we are having? Y is equals to the admittance, which is nothing but J omega C I am having. J omega C. What is J omega? J omega is nothing but J into 314. 2 pi f, if at all we do, we will get in 314 only. 2 into pi into f. Therefore, here I will be having as 1399. See, I can write this as 1.3 or 1399 into 10 to the power of minus 9 by 160, I can say. For 160 kilometer length of the line, I am finding the admittance. So, in order to get this small y, I will be dividing this with y, because here in capital Y only I will be multiplying with L. In small y, I don't need a y. So, whatever the value I will be getting here, I have to divide it by that value. I have to divide it by value. All of you get it cleared. Is it clear for you? Why am I divided by 160 over here? Is it clear?
Clear.
Why I divided by 160? Please, I will tell once again you to me. Why I divided with it is, see here, this small y into L is equals to capital Y, right? Capital Y. Capital Y is nothing but the admittance. Now I am interested to find this small y. Small y is equals to capital Y by L I am doing. Capital Y by L I am doing. Why capital I? This is the admittance value I am having. See here, this is the admittance value I have already calculated in the previous slide. See what is the admittance value? Capacitance value is nothing but this value I have got. Okay, 1399 by 160 I am doing. This one I am doing with 160. So that I have multiplied with j omega, say j into 315 into this one by 160. If at all I do, I will be getting the small y. I will be getting the small y. In order to find the small y, and what there is a difference between the small y and capital Y. Small y is the for small differential length of the line. This capital Y is the total admittance in that particular line. Total admittance. So I need not multiply with 160. I have to divide it by 160. Y by 160. See here I have multiplied it 160 over here. So I have been dividing it here in order to get this small y. That's the reason why I have divided with 160. Okay. Now I will be getting the value as J. This value is J 2.7 2.745 into 10 to the power of minus 6 at an angle of 90. At an angle of 90 I am having. Okay. At an angle of 90. This is nothing but the y, small y. What is small z? Small z is, it has been given. This small z is equals to root over r square plus xl square. R square plus xl square. What is r square we are having without multiplying with 160? R square is nothing but 1557 whole square plus 0.3 39878 whole square. Okay, 398 whole square I'll be getting. I'll be getting the answer as 0.423. If I calculate this value, I'll be getting 0.4280. 4280 I'll be getting with an angle of 68.03 or 68.67. 68.67, whatever it may be, what angle you'll be getting. See, you please note it down here. Now I know the value of small y and small z. I can find the gamma value. Gamma is nothing but root over yz. Root over y capital Y small y into small z. That is nothing but the gamma. Okay. Now gamma is called as what? If it is multiplied with the total length of the line, then we can say it as root over yz. See, I will be multiplying each and every term. This term and this term is multiplied, and finally I will be multiplying with 160, so that I will be getting root over yz I will be getting. Okay. See this one. What is small y I am having? J into 2.745 into 10 to the power of minus 6 into 10 to the power of minus 6 at an angle 90. See here, angle I'll place here at an angle 90. First angle with this one, 90 is multiplied with what is z we are having, 0.4280. 4280 I'm having, and the angle is nothing but see plus 68 plus I'll be adding this angle 68 point something 67 I'm having, right? So these on simplification I'll be getting the Excel value as, see here, what is the gamma value I'll be getting? Gamma value is nothing but gamma is equals to what else I will be getting? See 0.032 plus J 0.17. J 0.17. Okay. Now this is the value of gamma we are having. Now we know the value of gamma L, which is nothing but gamma into L. This is nothing but gamma into L, what we are doing now. See, this gamma into L is this value, right? Gamma into L value is this one. Whatever we are having is gamma into L value. Now, A is equals to, I can represent this in the two equations I told you just now, cos gamma L. See, this can be written as cos H root y into z. This is similar to this one. Just now, whenever we started the class, I've shown you already that VS equations both are same. In place of gamma L, I can place root yz. Root yz I can place. I told you already. So that is equal to this. We know the value of z. We know the value of y. Can we calculate cos hy from the series? We know the series. No, 1 plus yz by 2. 1 plus yz by 2, this is the series what I am having for this, yz by 2 plus yz by 24, y square z square by y square z square by 24. Okay, this is the what we need to know. Now after knowing this one, let us simplify all these equations. You know the value of y, you know the value of z. Substitute in this equation, you will be getting the value as this much. All of you try for it. I'll be asking you in tomorrow's class. All of you please try for it. 0.9558 into 0.32. 0.32 degrees. Okay. Now B is equals to, what is B? B is equals to root over Z by Y. I can write it as root over Z by Y, capital Z by Y, sine hyperbolic, root over YZ. I know this formula. But this is similar to this one. This is similar to, we can write this one as like this also, ZC into, in terms of propagation constant, if we want to write sin H gamma L, I can write. Sin H gamma L, I can write. How can I simplify this equation? Z into sin H sin root. Let us this equation I have simplified many times. Root over Z by Y sin H root YZ can be simplified as 1 plus YZ by 6 YZ by 6 plus YZ by Y square Z square. Y square Z square by 120 I can say. By 120 plus so on. Plus so on. We are bothered about first two terms only. We don't bother about the remaining ones. So let us have a, yeah, that is equals to, what is the value I've got? 67.7. All of you make a note of it and solve for it. Solve for it at home, whether you have got this answer or not. Just check it once. You please see the procedure. It's very, very important. The concept what I am telling. Okay. C is equals to root over y by z. I am having this formula. C is equals to root over y by z. Again, sine hyperbolic, sine hyperbolic root over yz, that is equals to, we can write the C equation as y into, see here, this can be written as sine hyperbolic, this can be written as sine hyperbolic gamma L by ZC, we can see. ZC is equals to what? Root over Z by Y. ZC is equals to root over Z by Y, we know. So we know the values, all these values, we can simplify these values so that we'll be getting this C as how much? We'll be getting as 4.3. Simplify it all of you at home. 4.3 into 10 to the power of minus 4, 10 to the power of minus 4 at an angle of 90 degrees. At an angle of 90 degrees. Now A is equals to D. A is equals to D. We are having. Okay. This is nothing but A is equals to D. Now here VR is taken as reference. Remaining procedure is all same. How to calculate the remaining procedure? Once after knowing the ABCD values, you have to find the VR. What is VR? VR is taken as a reference. VR is equals to VL by root 3 as we all know. VL by root 3 we all know. So substitute here in VL by root 3 is equals to, see what is VL we are having. VL is equals to how much here given you in the data? 132 into 10 cube into 10 cube by root 3. How much it is? Anyone of you, can you tell? What is the value of this? Value of this 76210. 210 it is. 76210. Have you got this value? 76210.
Yes, ma'am.
76210 you have got, right. Now let us calculate the load current. Load current. How to calculate the load current? See, the load current is equals to, see, it is given in 50 MVA rating. So 50, you need not multiply the denominator with cos phi if at all it is given in MVA rating. Only if at all it is given in megawatts, you have to multiply. If it is given in MVA rating, this you need not multiply. In the denominator, you need not multiply with cos phi. Why I told you many times. What is this? Cos phi is equals to kilowatts by kVA rating. kVA, if you want kilowatts by cos phi, it gives you. So it means that this value is nothing but kilowatt by cos phi value. You need not multiply denominator. Here you need not multiply with cos phi. Okay. This gets cancelled with 3 times. And we'll be having finally equation is equals to IR would be equal to 218.68 218.68 amperes. Okay, 218.68 amperes. Now let us calculate for Vs. See here in Vs calculations, we know the value of A, we know the value of A into VR value we know. See, V into IR. V value we know and IR value we know. Let us substitute all these values over here and finally please substitute these values whatever you are having. So you will finally you will be getting the angle as 87.95 87.95 at an angle of 5.6 5.624. Let us suppose you are getting the angle. Now calculate for IS. All values we know, A we know, B we know, VR we know and IR we know. Let us simplify all these values and put these values in this equation and calculate for this. Similarly, C into VR plus D into IR plus D into IR. These values also you know what is IR and all that. IR is this much, VR is this much with an angle of VR is equals to this is the angle what we are having for VS and sending in current. Let us substitute all these values and you will be getting the current value as this is the value what we are obtaining 197.75 at an angle of minus 28.9 minus 28.9 we are having. Okay, now is the cos of these angles. What is cos phi s? Can anyone of you tell you what is cos phi s? Cos phi s is the cosine angle between voltage and current, right? Cosine angle between voltage and current. What is the voltage angle? Here we are having current angle is minus 28.9 minus 5.62. 5.62. Please do it in calculus. You tell me the answer. How much you'll get? What is the cos value? Cos phi s. How much you get? Please tell me. It is 0.86. Have you got? Have you got this value? Cos of minus 28.9 minus 5.6. Minus 28.9 minus 5.6 gives you the 34 something odd. You'll be getting cos. If you apply for that, you'll be getting the cos phi s, which is nothing but 0.856 or like that you'll be getting. Have you got that value or not?
Yes, ma'am.
Yeah, 0.856 we have got or 86 or 856 you have got. Okay, once after knowing the value of cos phi s, what you have to do? You have to find the sending end power. What is the sending end power we have to find? See here, this is the sending end power. Sending power is equals to 3 into Vs into Is into cos phi s. Vs, Is, cos phi s. What is this Vs we are having? See, this Vs is nothing but the 3 into 79.8, 87.95 is nothing but the, what is this value we are having? Vs is nothing but 87.95. Let us substitute all these values were here. All we know, these all values 3 into Vs value is 87.95. Here you have got this value, this one 87.95. What is the Is value we are having? This is 197.75. What is cos phi s we are having? 0.859. 0.856 or like that you will be getting. How much is this value? Sending in power value? Can any one of you tell? What is the sending in power? 44690 have you got? What is the value you have got, ma? 43278 or something like that you will be getting. Let us suppose it is 43278. 278, okay, in kilowatts you will be getting. Now we want to find the regulation. VR dash naught we want to find. But we know the formula for VR is equals to VR is equals to, when Vs is equals to A into VR, A into VR plus B into IR, B into IR. I know this value. Since at no load voltage, if you want to find no load voltage means IR would be equal to 0. IR would be, no load means IR would be equal to 0. If IR is 0, this whole term gets 0. This whole term gets cancelled. You will be remaining with this term. What is VR at, this is nothing but VR at no load it will be giving you. So VR at no load, or you can represent like this, or VR at no load, we can represent like this. VR at no load is equals to, what else we are having? Vs by A. Vs by A. Very, very important. So what is voltage regulation? Percentage regulation. Percentage regulation is equals to VR at no load. See, this is nothing but VR at no load minus VR at full load by VR at full load, we can say. VR at full load, we can say. What is the value of this VR value? Whenever you do Vs by A, how much is this value? See, Vs by A value I will be keeping here. All of you make a note of it. Very, very important. 87.95 I am getting here. 87.95 by A value is 0.9855. 9855 I am getting. This on simplification you will be getting how much? 89.4. 89.244 is the value. That value I have to substitute over here. 89.244 is this value. 244 is this value minus VR value is nothing but 76.208. Okay. by 76.208. If at all you do this in megawatts, if at all you do this, then it is called as into 100 into 100 kVA. That is equals to 17.1 I will be getting. What are you getting? 17.1 percentage I am getting. Okay, regulation I have got this much. Now efficiency calculations. Efficiency, percentage efficiency is equals to percentage efficiency is equals to output power by input power by input power. This output power is in mega kVA rating, so I multiplied with 0.8 power factor. I have to multiply here at the efficiency. So output power is equals to 50 MVA. 50 MVA. So 50 into 000 into 0.8 by 44690 into 100 into 100. If at all you do, how much you will be getting? 44 or 42? 43 it is of 43 43278, sorry, 278. 43278. How much you are getting? 43278. It is around 90 something odd you will be getting. Please try it. How much you will be getting? Test it. Tell me. Tell me how much you have got. Let me calculate here. It is of 50 into 1000 into 0.8 divided by 43278 into 100, which is given as 92.4, right? 92.4%. With this, we have completed how to calculate the efficiency calculation, sending and voltage calculation, sending and this one. What do you mean by sending and power factor? Can any one of you tell? We have calculated everything. With this, we have completed your problem. Okay? Which is very, very important. Okay, students, those who have doubts, you can ask me, or else those who don't have doubts, you can leave the class.